Danger! Proceed with caution. Only watch the following video after you have attempted numbers 38, 40, and 42 on your own. You've been warned. All right, everybody. This is going to be a fun one because normally I preview the problems, but I haven't for this one. So let's just, fly through them. And if I have to use a calculator or something like that, this video could take a little longer. I hope it doesn't, though. Here we go. Number 38. How many terms are in the arithmetic sequence? 178, 170, ... That one's for you, Mrs. Edson. 2. Okay, well, let's find out. This means that it's going down by 8. This is my first term. This is my last term. Last term, but I'm also going to call it P sub n. Okay? So here we go. Here we go. Here we go. Here we go. So if I was going to mess around with figuring out how many terms are in this sequence, I would have to use the arithmetic sequence, which says take the first term, 178, add on n minus 1, have no idea what n is, and then multiply it by the difference, -8. However, the nth term is how many terms there are. The last term is going to represent that, and I know that that answer is 2. Okay, let's go. Let's go! 178 minus 8n plus 8 equals 2. 186 minus 8n equals 2. -8n equals -184. Yikes. Here we go. Hello, pink calculator. Clear. 184 divided by 8. Hey, look at that. 23. The number 23. I mean, I wouldn't recommend watching that movie, but there are some weird little YouTube videos about people being really freaked out about the number 23 and how it shows up in history and in nature and a lot of different things. I think Jim Carrey was in a movie called The Number 23 also, which was really weird. Next. Number 40. Number 40 says, find the number of multiples of 6. Multiples of 6. Ranging from 28 all the way to 280. And you're like, hey, does 6 go into 28? No, it doesn't. But, or sorry, does 6 go into 28 evenly? No, it doesn't. But 30, yeah, 30 works, okay? And then I get out my handy dandy calculator and I'm like, hey, is 280 divisible by 6? Question mark. No, it was 46.7. So I'm going to take off the 0.7. I'm going to take 46 times 6 and get that it goes all the way to 276. Okay, so my terms this time, like we had last time, my terms this time are going to be 30. 36 because it's a multiple of 6. I wrote 360 because that's a circle. ... all the way to 276. Okay, those are the multiples of 6 there. I could write them all out, but I'm not going to. I'm just going to do what I did on the previous problem. First term, 30 plus n minus 1 times d, which is 6, and that's going to equal the last term, which is 276. I'm going to draw this to your line. Bloop. Did that one there also for number 1 fan. And so that's going to be 30 plus 6n minus 6 equals 276. That's 24 plus 6n equaling 2, 7, 6. 6n equals 252. And then, hello, pink calculator. 252 divided by 6, 42. Well, how about that? Looky there. Looky there. I got a bite. It's a country song. Well, I'm gonna miss her. Okay, so that is number 40. Okay, and now for number 40, hello, 2. It's raining outside. I didn't even run this morning because, like at 2 a.m., Mindy jumps on the bed and says, "Hey, it's raining outside," like that to me. And I'm like, oh, you know what I mean? Number 42. How many 4-digit numbers are not divisible by 11? What in the snap are we talking about now? How many 4-digit numbers, 4-digit numbers not divisible by 11? Okay, I don't know. Let's find out. All right, so 4-digit numbers range from 1,000 all the way to 9,999. By the way, this is the first year that I've written my nines like that. Normally I'd write them like that, but people really did not like those. I mean, for years. And if we go back, did I write a 9 on this problem? No. Did I write a 9 on this problem? Interesting. My first 9. Okay, here we go. So you're like, what? Well, what I'm going to do is figure out how many are first. Let's figure out how many numbers are divisible by 11. Okay, so it's just like the previous problem. I'm going to take 1,000. I'm going to divide it by 11. I know it's not divisible. It's 90.9. So I'm going to raise that to 91. So I'm going to take 91 times 11, and that means that my first term is 1,001. And then there's a good chance 9,999 is divisible by 11. Oh, yeah, it is. Okay, so I got that. It sure did. It went in there 909 times. So it's going to go all the way to 9999. Brooks, that reminds me of that meme or that joke that I sent you about those tennis shoes. That was funny, wasn't it? It's an inside joke. You guys wouldn't get it, obviously, because you don't know about it at all. All right, so divisible by 11, which means, like, if I was looking at a pattern, it would be 1,001. Then I'm going to add 11 to that. It'd be 1,012, and then dot 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 999. All right, and you're like, I don't think you're sure, Mr. Blanchard, that 1,012 is divisible by 11. Heck yeah, it is. Goes in there 92 times. Okay, and so this is arithmetic. I'm going to use black ink now. Here we go. So it's going to be the first term plus n minus 1 times 11. But I know that that last answer is 9, 9, 9, 9. Okay, there we go. There we go. Okay, so it's 1,001 plus 11 and minus 11 equals, I'm not going to say it. I'm not even going to write the nines like that. Rebel. Okay, so what's 1,001 minus 11? 990. So then I'm going to subtract that. So I'm going to get 11n. I'm saving some space here because we still have some work to do. 11n equals 9,009. Then I divide by 11 and get 819. Okay, 819. That's how many are divisible. Are divisible. Got it? Okay, now here comes the tricky part. So that's are divisible. There we go. By 11. But this question says how many aren't? Okay. So if I knew how many four-digit numbers there were, I could just subtract 819 and get the right answer, okay? And this is a big common mistake that people do. They say, well, that's easy. It goes from 1,000 to 9,999. I'm just going to subtract those, and I'm going to say that there's 8,999 terms, and that is incorrect, okay? When you subtract 9,999 minus 1,000, that means that you're not including 1,000, okay? So I have to include 1,000 in there also, okay? So that would give me 9,000 terms, okay? So I'm going to put a question mark here, and the answer was no, it's not 8,999. It's 9,000 terms. Go ahead, count them on your finger, like, if you don't believe me, because when you started counting on your finger, you go 1,000, that would be your thumb. 1,001, that'd be your pointer finger. 1,002, that'd be your middle finger, right? And so that is the 1,000. When you put your thumb up for that, that means you're counting that 1,000. But when you subtract the 1,000, that means don't count it, but you have to count it. Okay, so there's 9,000 terms. So then all I have to do is subtract 819, and I get 8181, not divisible by 11, which is quite a few. Like, that's a really, really high percentage, but 11's a prime number, so obviously it's going to be, you know, a pretty big number out of 9,000. All right, so there you are, and there you have it. Let's see, today is what, Wednesday? Isn't that weird? We lose track of, hey, what day is it? So that means tomorrow, are we moving on to a different, we are. All right. We're moving on to a different page tomorrow. We're moving on to 481, which is recursive definitions, which is, I don't know. I mean, it's pretty cool. It's pretty self-explanatory. I think you'll like it. I mean, I like it. All right, so don't forget, everybody, that you guys should subscribe to my channel. Subscribe right here. I don't have a YouTube account. Yeah, you do. And these are your class videos, just in case you think you're missing something. Do. All right, I'm going to stop this one at 1414. And I say to you, good day.